I know this is already out of order, but okay. So it says question 3 here. Independent simple random samples are selected to test the difference. That's somewhat important between the two means of two populations whose variances are not known. Super important there. So whenever you're testing the differences between two means, it's either an X or a T or a normal. You can think of a normal or a T. Binomial is not used here. Binomials for something else, which isn't even related. Poisson, same thing. And then uniform, kind of same thing. So you're down to these two. When it's not known, the variances are not known. That's when you use T. Normal is when they are known. That's how you decide on a question like this one.
Okay. I was just that one, like, I didn't really know when to use what, so that actually helps a lot, knowing if it's not known, it's T, and if it's known, it's normal.
Yes, these other ones are just, they're out of place completely, but they're there. So
Okay.
all right. Okay, so next question, snipping in, this one's 25. It says you're given partial computer output. I don't know what it is. Okay, based on a sample of 16 observations. Okay, so the T value, I believe, comes from dividing these numbers here.
Yeah, the equation she gave us for the T value is BI over SBI. And it says SBI
So
is a
this,
standard.
so yeah, so that's what I'm gonna say is it's this divided by this. Used to test the T value obtained from the table, which is used to test an individual parameter at the 1% level is, it's really weird because it's not saying which one. Individual parameter. Unless it's looking for something else. Okay, let me just divide these and see if I can rule out any numbers.
I divided all the standard errors and the coefficients, and all of them are like,
all of them are in this list.
no, they're all less than one. Because you do standard error divided by a coefficient, right?
No,
It's the other way around. Sorry. That's my fault.
Yeah, no big deal.
Okay.
These formulas don't mean anything unless you do this all the time. The first one is 2.903. Next one's negative, so I know it's out, but I'll do it anyway here.
It's negative 2.903 as well.
And then this other one is maybe the same.
This the last one is the 3.6. Yeah.
Ish. So none of these are here. Wonderful. The other thing is that it's possibly asking you to like get the critical value, which I don't actually like see in this language, but I don't know what else it could be. But the critical value requires knowing the degrees of freedom, which you get from so you would take, I think, the sum of squares and divide by the degrees of freedom to get the mean square. Maybe let me see if that gives us a reasonably nice number. Oh yeah, it does. It would just be 2.
Okay.
Oh no, there it is. There it is. I'm sorry. That's what I was looking for. Okay. Thank goodness. Okay. Wow. I couldn't find that number. So when you're doing now I got to remember this. Your T critical. I don't remember if it's n-1 or n-2 for regression. So I have to look that up, but that's probably gonna give us our answer here. Regression degrees of freedom formula. Critical value, it's n-2. So in yours, it's going to be You gotta look this up. This 0.99 comma 16 minus 2. Are you using a table for that or your calculator or something else?
I could use my calculator.
Okay. The number I got here is, there it is, 2.625.
Okay, wait, I'm confused what the T.99 is.
So the idea is because it's 1%, there's 1% in the tail here
Oh,
and 0.99 over here, which is
okay.
the calculator I use. It's left tailed, so I have to do that. Yours might be, you might have a right tail option for that.
Okay. So then. Okay. I see now. I was so confused by that, what it meant by the 1% level, but I see
Yeah.
now.
So when it said from the table, it's not referring to this output, which we would assume is the table. It's referring to the like T table.
Okay, and that will get, like, we get a T table. So then
Yeah.
it's gonna be 2.6. Okay,
Yes.
because if I look at 14 at 0.01, it's 2.624, but I look at 13, right?
Well, so I mean, it's really close. The one I have was, it was 2.6449, which rounds that up and that up.
Okay,
It's the one that I would, consider most reasonable.
okay. Okay, that makes sense.
All right, so next question here is 22. This one's actually easier to do. It's the same table, meaning like, I'm sorry, the same output. Let me snip this in. Okay, so the F value. Oh, I'm sorry. Again, this one is not, sorry about that. It says the F value obtained from the table. What this is referring to, it's not referring to this. It's really should say the critical value is what you're trying to find.
Okay,
So your F critical has 2 degrees of freedom. It has one for the regression and then one for the error. So we actually do need the table here, but let me get those values. So the first one is 2. Now, how did Matthew get to? It's 4853 divided by 2426.5.
okay,
So that's how you get 2. Now the total, which is not here, the total is, I believe, the number of observations minus 1. So for you, it's gonna be 16 minus 1, which is 15.
okay,
And then the regression and the error have to add up to that.
okay,
So you're gonna look for something at 0.99 or 0.01, depending on how you want to do it, comma 2, comma 13. Probably want to double check this, depends on the table, row and column for that to get those values with your notes, or if you're doing it with your calculator. I don't remember if the TI 8384 will do this. So when I do this in mine, I don't get any of the numbers. That's not good. Let me go the other way. That didn't work either. I must not have this right. Let me see if I change that second number. Maybe there is something that I am missing. Wait, it is 16 observations. So the other possibility is it actually is looking for this number here, which is the ratio of these.
okay.
which I don't know why it would be, but that's 2426.5 divided by 485.3. That's the F value of the test. Well, that is exactly 5.1 level. Is this possibly a two-tailed test? I'm trying to figure out how to get one of these numbers on there. It comes from these.
Mm,
2 comma. No.
Would knowing the answer help? Because I have that
What is the answer? Sure.
5.74.
So that's the answer. When I first did it, my critical value was like 6.52, which was too far away, but it was, I mean, it was kind of okay. Why would it be like 30? Would it be 30? 31? There's 2 coefficients. Regression error. There's something I'm not, there's like, it must be, there's something else here I'm not seeing, kind of like the last problem where we had to figure out that it was that. Let's move on. Make sure I get your questions answered. Some of them wouldn't be that hard here. Okay. I guess I'll go to this question too. Look at that. Okay. The results of a recent poll and the preference of teenagers regarding the type of music they listen to are shown below. So this is like X and this is N. And then you generally need a P1, which is 384 over 800, and then a P2, which is 450 over 900. Your calculator will do a 2 sample prop z-test, proportion z-test for this, but they want the standard error here, and that's a formula. So you have to know that it's, I believe it's P bar 1 minus P bar over your big N. Do you have something like that for a 2 sample proportion in your notes somewhere in a reference sheet?
For the equation, I have it's rad p bar times 1 minus p bar times 1 over n1 plus 1 over n2. Would that make sense?
Yeah, because the big N represents the, so yes, this is going to, so your P bar, which is a little weird, is 384 plus 450 over 800 plus 900. It's the ones that in both groups that worked out, and then your big N is this 1700.
Okay.
So let me see if I can get this calculation here. See if I can get this, because you did say, you said it was like 1 over n1 plus 1 over n2, like that.
Yeah.
That might actually make a difference. So let me do it that way without thinking much about it. Okay, so P is 384 plus, oops, 384 plus 450 divided by 800 plus 900. Okay, so P is like 0.49-ish, but you don't want to round, you want to use that full number. So it's the square root minus P 1 over 800 plus 1 over Oops, I didn't finish that calculation. There it is. And so I get the third answer here using this formula here. So
Okay,
it's this is P bar, and then it's 1 over 800 plus 1 over 900. This is the type of problem where if you don't, like, even if you have a calculator, like the calculator doesn't give you this standard error. You have to calculate it on your own
yeah,
through the formula.
okay. That makes sense. I just want to make sure I was using the right equation for that one.
That looks good. Okay, moving on. If my speed isn't good, I can go a little faster here. I see 21 is back to that multiple regression thing. Okay, so this time it says we want to test whether parameter B1 is significant. There's your, this is B1, even though it doesn't say it. So you have to divide these numbers.
Okay,
And
that one I knew how to do it. Like I got to it obviously, but I wanted to make sure that, so would X2 then be considered B2 if it were to ask?
exactly. And that
Okay.
constant is B0.
Okay, that's exactly
Betas
what I
are,
needed.
yeah. Okay,
Okay,
great. Next one is 5. Snip this in. Refer to exhibit 10-11. Okay, so this information up here, and PU represents the proportion under and P0 the portion over 18. Okay, the null hypothesis is, so this last one is out because the null has to always be equal to, greater than or equal to, or less than or equal to.
Okay.
Okay, and then we got to go back towards, we're interested in determining if the accident proportion differs. So that just means that we don't care whether it's bigger or smaller, just differ. And that's why this is the right answer. If it said we're interested in determining whether the accident proportion is greater for under and over, then we'd have to do something different.
Okay, I was just wondering why it wouldn't be the first option. Wait. Yeah.
So this is the null. The null is, so this is actually referring to the alternative. And there's
Okay.
kind of this table, like if your null is an equal, the alternative is a not equal. If your null is a greater than or equal to, your alternative is a less than. If it's a less than or equal to, it's a greater than.
Okay.
So the claim is generally in the alternative
Okay.
hypothesis.
Okay, that makes sense.
I'll just make a small comment here that sometimes it's you want to actually put numbers in. Like if you think the claims are more for those under 18, like let's say you think that there are there's like 0.7 more claims for under 18 and 0.5 for over 18. When you subtract these, you get a positive number.
Mhm.
And that sometimes help you to figure out like which direction it should go, because
Okay.
you can maybe guess wrong if you don't like try to see, well, does that actually work with the numbers that I think are reasonable.
Okay.
All right, so 21 is the next one I'm seeing here. Following equation, yearly income, thousands, 30 individuals, age X1, their gender X2, 0 if male and 1 if female. Okay. It's also provided sum of squares. Okay, then we don't care about that.
This one
Yearly
I think
income.
I actually figured out because would it be 24-year-old woman? And
So 24, and because her gender is female, you put a 1 there.
okay, and then
And that's,
I literally think I figured this one out right after I screenshotted it.
okay, good.
Yeah, and it equals 49.88. Okay.
Yeah, sounds right. Just make sure you choose, the one that's actually in.
Yes.
Wait, that's wrong. That one is wrong. Because it says in thousands, because you get 49.8 here. Wait a second.
Yeah.
So I guess I would still say that's right, because that is the income, but that's not the value of Y. Y is 49.8, but it's unitless.
Okay. And this was, I can see what the answer is.
I think it's this last one, because it is saying yearly income, not, as a
Yeah, the
tens.
correct answer is the thousands.
Yeah.
Okay.
Okay, so the next one is 18, the same kind of thing here. All right, for this model, okay, the coefficient of the unit price. So which one's the unit price? The unit price is X1. There's X1. Okay, so this one, if unit price, it's always this way. You always want the one that says increased. These other two are wrong. If you increase it and then the sign tells you whether it goes up or down. So we're looking for the one that says,
Wouldn't it be the last one because it says increase by $1?
oh, that is, yeah, I got too excited by
You're good.
So yeah, so that's the one that now decreases because it's 4, and that's because it's negative, and then it's in thousands of dollars.
Okay,
Somewhere
and if
says
it
that.
were to be like positive, then it would just be the increase one.
Yes,
Okay, that's easy.
yes. It's kind of a recipe. You just plug in the ones that work in your mind with those. Okay, so we got another question 5. We got a bunch of question 5s. Okay, it's the value of the test statistic. You could do this in your calculator. Actually, that's the wrong. It's a Z. It's a 2 sample prop Z test. Are you allowed to use your calculator?
I don't know. Like we're allowed to use our calculator, but I'm not sure how I would do that on the calculator. I never
Okay,
learned it.
that's fine. So you still need this P bar, which is 500 plus 600. Oops, that's wrong. It's the other numbers. It's the 180 plus 150 over 500 plus 600. So you need that. We'll get that number in a moment. Your standard error we just did in a previous problem. It's the square root of P bar, 1
Yeah.
minus P bar times 1 over N1 plus 1 over N2. We need that number as well. So your Z is P1 minus P2 over your standard error.
Okay.
So we need this number, the P bar, to lead to the next number, which we will get. I just need to get the calculation here going. So this is actually 0.3. Shocked that worked out so nicely. So it's 0.3 times 1 minus 0.3, 1 over 500 plus 1 over 600 square rooted. Let me get that for you. So that's not as nice, but it's approximately 0.02775. And then P1 is that first proportion. It's the 180 over 500 minus 150 over 600, all over this 0.02775. And the reason I was asking about the calculator is because you can, there's a test where it just gives you these numbers.
Oh, okay.
Just gives, so I get 3.96 when I do that.
Okay. That makes sense.
Okay, so the next question here, question 10. Exhibit. It's really okay. So they ask you for the test statistic for beta 1, and here they actually calculate them for you. So the intercept is beta 0, the income is beta 1.
Okay.
So wait a second. Why are they doing this way? There's your t-stat. Why isn't that here? Okay, now we look at this a little more. What is the test statistic when testing the beta B1 equals 1.1? So why would they do this? Normally you test that your betas equal 0. That's like a normal one. And so
Okay.
like you can imagine if you were to subtract 0 from both sides, you get beta 1 minus 0.
Okay.
But these are all negative. So why would they do that? Something not right here. So there are 12 samples. What's the test statistic? I mean, I hate this question, but is there anything else? I mean, nope, this is truly everything. I'm trying to figure out if there's like if this is like that one earlier where it was asking for the critical value instead. I'm not even sure how to get some of these numbers because they're all negative too. That's also weird. Why would they be negative? Do you know the answer to this?
Yeah, I can figure it out. Just give me 1 second. Negative 3.999.
Okay, let me check on something else here. So this is a t-test. QF and 0.99 would be negative. I mean, is there any chance that this is wrong? That like the computer generated this and it's just like it's, I mean, this doesn't make any, I mean, this isn't even, the test statistic is this. I mean, it's the 1.4968. I'm sorry, 2.6691 for the beta 1.
There honestly, like, there could be a good chance it's incorrect.
I hate saying that though, but this number is supposed to represent the test statistic, like when you do it, so you don't have to figure it out. Plus, these are all the wrong sign. Like this is positive. I don't know.
Yeah.
I'm sorry. I don't really even know where to lead you down this road
It's okay.
to give you a better answer. All right. We got some time left. Are there some other questions you would like us to look at?
I just have some like, I wrote some questions down while I was doing it, like what I,
Could you just could we just pause for 30 seconds? I need to get a drink of water. Be right
Yeah,
back.
you're
if
good.
That's okay with you. All right, I'm back.
There, I like wrote down some questions when I was doing it, but then I figured out most of them. Like, the only thing is, I don't know if you'd know how to answer this, but I mean, I guess it says in the questions most of the time, but sometimes when it says like, what is the test statistic? How do I know when to use like F test statistic or T test statistic, if you know what I'm saying?
Yeah. So the like for example, when you're testing the overall regression model, that is an F test. Okay. When you're testing individual coefficients, that is a T test.
Okay.
Oh, maybe that is the answer to that. T squared of that. No. So there's a relationship between this F, but that's not even close to being right. Okay, sorry. Squared, B squared. Nope. Okay.
Other than that, I don't think I had any other questions.
And let's go back and look at. I think there's one other one where I just said I don't know why it's this number. This one right here. I mean, you got to be careful. Like, is our assumption that this is actually the right answer because it's actually the right thing? We're trying to figure that out here as well.
Mhm.
This is to test if there's a relationship among the variables. So that to me is like the model, which is
Okay.
why we were doing an F test on it. Maybe I had the wrong number. No, that seems right. Back. Let me do it backwards here. No, that's 0.99. Nope, that's not even close. Yeah, I still don't find a good way to get to that number.
Okay.
I'm trying on another program here to figure out the degrees of freedom that it might have been to give us like some insight into that, but that's not even working. Yeah. I don't know if you have the ability to email your instructor, maybe that would help.
Yeah. I'll figure it out.
Okay. What else? What else can we look at? Any other questions? Some more, I don't know, stuff like this. Do you need any help in sort of like overall macro level, like understanding of things? We did some proportions. Analyzing models.
I really don't think so. I think that was it. I just had that actually helped a lot.
Great. Well, I appreciate you scheduling. I'll send you the notes and the screen recording here shortly, and I'll see you next time. If hopefully I can help you again.
All right, thank you.
You're welcome. Bye now.